Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. First thing we need to do is work out the area of the wall. And so to do that, we're just going to multiply the 44 by the 40. So 44 times 40 is 1,760. And next thing we notice is that each tin covers 10 meters squared. So it actually means we can work out the fact that there are 1,760 meters squared in total for our wall. And if each tin covers 10 meters squared, then we will need 176 tins. That's the amount of tins we need. And each tin costs £5.70, so it would be 176 times the 5.7, or £5.70, or you could do it as 570 pence and convert it at the end. And that gives us a price of 1,003.2. And so as money, that would be £1,003.20. There's a formula we use for this, and it is percentage change is equal to the amount that's changed over the original amount, and all of that times 100%. So how much has changed here? Well, we need to do 10,488 take away 10,254, so that would be 234. Divide it by the original, so the original was 10,488 because it's decreased from that amount, and then times by 100%. And so that's going to be 2.23%. So the only options for the next card are for them to be higher, lower, or equal to 12. We already know that the probability for it being higher is 19% and lower is 28%, and all probabilities have to add up to 1, or in this case, because it's percentages, 100%. So to work out the probability that is missing, we're going to take away the 19% and the 28% away from 100% to see what's left, and that's 53%. To answer this question, we need to cut this shape into two shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20, the length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimetres, and so the area units will be centimetres squared. So we've got to first of all make these both the same units, because at the moment they are different units, and when we have ratios we always want to make sure that they have the same units, and then we can get rid of the units. So I'm just going to make them both into grams. I'm going to do that by timesing the right by 1,000. And the reason I've chosen grams rather than kilograms is you want to always pick the smaller unit. Otherwise you'd be left with a decimal on the left hand side, you'd be 0.2, and that can be a bit more complicated. Okay, so I'm going to remove the units now, and we're just going to focus on the numbers. So we can divide both sides by 100 straight off the bat. So we've got 2 to 40. We can see we can divide them both by 2. And so we've got 1 to 20. And so it's 1 gram to 20 grams, or just 1 to 20. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. A sample space diagram is basically a diagram that shows all the outcomes, and we've got the outcomes from spinner 2 at the top, so either 1, 2 or 3, and we've got the outcomes from spinner 1 down the side, so A, B, C, D or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinners. So when simplifying ratio, it's very similar to simplifying fractions, but instead of the same thing having to do the same thing to the top and bottom, you have to do the same thing to the left and right. So I'm going to start here by dividing both sides by 100, because I notice they both have 2 zeros at the end. So that'll give me 10 here and 34 here. Now these are both even numbers, so a nice easy next one to do is dividing by 2. And we get, was it 17? And 5 and 17, well, they're both prime numbers, and so there's nothing we can cancel them by, so it's going to be our answer, 5 to 17. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100, which gives us 1.015. And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. So the first thing we're going to do is work out the area of the trapezium. And the formula for that is half brackets a plus b times h. Now a and b have to be the parallel sides. So here we've got the two parallel sides here, which just pick a different colour, here and here. So that is a and b. And then the h is the perpendicular distance between them. So perpendicular means it hits it at right angles, so that's what we've got here. So the area would be half times A, which is 28, plus B, which is 14, times the height, which is 14. And so that would be 294. Next we'll do the circle. Now it doesn't look like we've got anything for the circle, but actually the height here is actually the height of the circle as well. So the height of the circle is the same as the diameter. So the diameter of the circle is 14, therefore the radius would be half of that, which is 7, and the area of a circle is pi times the radius squared. So it would be pi times 7 squared, which will be 153.938 blah blah blah. Now I'll keep that in my calculator, because next thing we'll do is the shaded area part, and it says we want to work out the area of the shaded region. So the area will be the total area, which will be the trapezium, take away the area that we don't want, which is this bit here, which will be the circle. So the trapezium's 294, the circle's 153.93 blah blah blah, and when you do that you get 140.061 blah blah blah. It says it wants it to 2 decimal places, so it would be 140.06. To prove triangle congruence, you're going to have one of 4 answers. You're either going to have RHS, SSS, angle, angle, side, or angle, side, angle, and the last one, side, angle, side. So those are our options. So we've got to figure out what we have in this question. Well, we have a right angle, so an angle or right angle. We've got a side, which is actually the hypotenuse, because we know the hypotenuse is opposite the right angle. And then we just have another side. Now, it's not going to be SSS because we don't have 3 sides. We do have a side and an angle and a side, but the 2 sides are not next to the angle, so it's not going to be that one. And we don't have 2 angles, so it's not going to be this one. So the last one is RHS, which is right angle, which we have, hypotenuse, which we have, and side. To work out the area of this prism, we need to first of all work out the area of the cross section, which is this part here, so this triangle here. So to do that, I'm going to do half times base times height. So it's going to be half times the base, which is 22, times the height, which is 14. That gives us 154. So the volume is the area of the cross section times the length. So the area of the cross section we've just found out is 154, and the length is basically how 3D the shape is. So that's going to be 15. So the answer is 2,310 centimeters cubed. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay? And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. There is quite an easy way of doing this question, but I'm going to show you the long way, and then we're going to work out what the quicker way is. So I'm going to pair up the a and the 1, which it suggests in the question. Then I'm going to work out the a and the 2 as a different combination, a3, a4, etc. Then I'm going to look at the b and do the same thing, b1, b2, b3, etc. Then I'm going to work out the c, so all the combinations with c. So how many combinations are there with a? Well, there's going to be 7 because there's 7 numbers. How many with b? Well, there's also going to be 7. And how many with c? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. To convert from meters to centimeters, we times by 100. But here we're asked to convert between meters cubed and centimeters cubed. So we times it by 100 per dimension. Meters cubed and centimeters cubed is volume, which is 3 dimensions. So what we do is we times it by 100 3 times, times 100, times 100, times 100, or times by 100 cubed. So we get our amount, 0.15, times it by 100 cubed, and that will give us 150,000. So our answer is 150,000 centimeters cubed. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. Integer just means whole number. So we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going until I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. The formula for the circumference of a circle is circumference equals pi times the diameter. In this question, we're given the fact that the circumference is 37.7 and we're asked to find the diameter. So if we put our lines in, all we need to do is divide both sides by pi. So we've got 37.7 divided by pi equals the diameter. And so that is, when you round, well, it's 12.00 blah blah blah. Round to the nearest integer, that would be 12 centimeters. And we can try it by typing in 12 times pi, and we get what would round to 37.7. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers, and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared, and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared, so that's another 3 zeros. You can see here that that's 1,000,000, so we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434. Blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33, and we can see here that the plus 9x and the minus 22x are like terms, so we can add them together to make minus 13x, and that's our answer. So our answer is 6x squared minus 13x minus 33. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3 over 5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If if we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcomes, the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3 over 5 times 2 over 4. And I realise I could cancel 2 over 4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2 over 5 times 3 over 4. So 2 over 5 times 3 over 4, 3/4. That would be 6 over 20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6 over 20 plus 6 over 20. And this is the probability of different, which will be 12 over 20. Now 12 over 20 will cancel to 3 over 5, or 3/5. So to do a cumulative frequency graph, we've got to first of all add a cumulative frequency column to our table. And cumulative frequency is just a running total. So we always start off with the first value, which is 10. Then we add the next value, so 10 plus 25 is 35. Then we add the next value, so that's going to be 50. Now, the cumulative frequency is the total amount so far. So, for that first 10, for the frequency of cumulative frequency of 10, we're looking at everything up until the 20. So, we plot it at the 20. So, it'd be 20 and then 10. So, this one here. Then the next one, the 35, is everything up until 40. So it would be here. And then the next one is everything up until 60. There we are. Now, next we want to join them up. Now you can draw them up with a curve, and in most exams you can actually join them up with straight lines. So something you can do is just join them up with, click the right one, straight lines like that. And on most exams that's absolutely fine. I'm going to join them up with a curve. There we go. Now technically I should really finish this off with a nice straight bit there, because there's just a constant 50 forevermore. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labelling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29. And we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that in the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79. And that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. So we've got Billy and James and Sam, and James collects 20% more sand than Billy. So we've got James and he's plus 20%. And Sam collects 60% more sand than James, 60%. And you'd think you'd just add the two. Obviously, it's not going to be that easy for 3 marks. So the answer is not 80. What we've got to do is find the multipliers for each of these. And so what we're going to do is we're going to start off with 100%, add the 20%, and that would be 120%. Then we're going to get the 120, divide it by 100, and that gives us the multiplier, which would be 1.2. So the multiplier from Billy to James is 1.2. So however much Billy has, if we times it by 1.2, we get James's amount. Do the same for James to Sam. So start off with 100%, add 60, is 160%. Then just make that a decimal, so 160 divided by 100, 1.6. So if we multiply anything by 1.6, it will increase it by 60%. Now it says, by what percentage is the amount of sand collected by Sam greater than the amount Billy? So what we're going to do is we're going to start off with Billy being 100%, okay? We're going to times it by the 1.2, and then times it by the 1.6, and find out what the final percentage is. So when we do that, we get 192. So we started off with Billy's 100, we just made that up, but it just makes the maths nicer to use. And we ended up with Sam having 192. Well, what is 192 as a percentage increase of 100? Well, the reason we picked 100 is we can clearly see that it's gone up by 92%. So our answer is 92%. You're expected to be able to draw a sine, cosine and tangent wave, and here we're asked to work out what y equals cos x looks like on a graph. Now cos x starts at 1, goes down to 0, then goes down to -1 at 180, then back up to 0 at 270, then back up to 1 at 360. But don't just join it up with straight lines. That will not get you any marks. You've got to make it look like a wave. And this is not the easiest thing to do, but they are very forgiving over how you do this. As long as it goes through the points, and as long as this bottom bit is a U shape and not a V shape, then normally you will get the mark. So although that doesn't look perfect, that would definitely get the marks. An exponential growth would show an increase from left to right, but the graph we've got in front of us, or the sketch, is showing it decreasing, so it's going to be a decay. So we're going to start off just by copying down the same equation, and we're asked to make B the subject. So we're going to put our solving lines in. So the first thing we need to do is get rid of this 10 here. So we're going to divide both sides by 10. And that will mean we have a fraction here, a over 10. And we've got the square root b over 3. Now we need to get rid of that square root. So what I'm going to do now is square both sides. Now to square a fraction, we square the top of the fraction and we square the bottom of the fraction. 10 squared is 100. And that will equal b over 3. And we want to get rid of this next, so we want to times both sides by 3. To get rid of a divide by 3, we times both sides by 3. Now with a fraction, when you times it by something, you actually just times the numerator, the top, by that. So it's going to be 3a squared over 100 equals b. So b is 3a squared over 100. In this question, it might be easier just to draw a quick diagram. So let's draw this equilateral triangle, and it says that its lengths are all 10 centimeters. And we're looking to find the area. Now we also know with an equilateral triangle, all the angles are 60 degrees. So we can plot those, but we don't need to plot them all, we can just plot one of them. And we know that to find the area of a triangle, we can use this formula here, which is half AB sine capital C. And if we have a look at this diagram, we can label the sides. So I'll call this side, this angle C, and little c here, and little a here, and little b here. So let's put that into our formula. Little a is 10, little b is 10, and sine c, which is 60. So with a, b and c, it doesn't matter what you label a, b and c, as long as the angle is opposite the side with the same letter. The angles are all capital letters, the lengths are all lowercase. Okay, so let's put that into our calculator and we get the answer of 43.301, blah blah blah. It says it wants it to 2 decimal places, so that is 43.3. So we're told that the two cuboids are similar, which means we're going to have a scale factor, and we can work out the linear scale factor straight away to find out what we times the 14 by to get to the 49. We're going to do 49 divided by 14, big one divided by small one, and that gives us 14, does it? No, 3.5. Okay, so we're going to times it by 3.5. So 14 times 3.5 is 49. But that is the linear scale factor. And this question is all about volumes. So we're looking at going from here to the volume of the smaller one. Okay. So whenever we go from the bigger to the smaller, we're going to divide by the scale factor. So we know we've got to find the scale factor and divide by it. But the volume scale factor is going to equal the linear scale factor cubed. because volume scale factor has 3 dimensions. Volume has 3 dimensions, therefore it's going to do the linear scale factor 3 times in a row, times 3.5, times 3.5, times 3.5, or 3.5 cubed. So the volume scale factor, we're just going to cube that 3.5, and we get 42.875. So it'd be 42.875. And so on our calculator, we're going to do 4,201.75 divided by the 42.875, and we get the answer 98. So we're going to start by labeling the sides here. So we've got capital A up here, little a down here. It doesn't matter which one you label. Capital B here, little b here, then capital C here, little c here. So you notice the C's aren't really involved at all, but we've got the two A's, we've got the capital A and the lowercase a, and we've got the capital B and the lowercase b as part of the question. And so when you've got a pair or two pairs of angle and sides, you are going to be using the sine rule. And so the sine rule says that sine capital A over lowercase a is equal to sine capital B over lowercase b. Now you might be wondering why I've put sine A and sine B at the top, when sometimes this is written as the lowercase a and lowercase b at the top. Well, if we're looking for the angle, which we are here, we're looking for capital A, you put the angles at the top. If you're looking for the length, you put the lengths at the top. Okay, so we're going to fill this in. So sine, we're just going to leave that as sine A, because it's just, or sine x actually, shouldn't it be? Sine x over, and then lowercase a is 6, equals sine B, the angle is 35, over lowercase b, which is 7. Okay, we're going to work out what the right hand side is. So that's going to be 0.081 blah blah blah. And then we're going to be solving this. And the first thing we're going to do is times by 6 both sides. So we get sine x is equal to 0.491 blah blah blah. And then we're going to inverse sine both sides. And so we have x equals 29.448 blah blah blah. And our answer wants to be rounded to 2 decimal places, so we're going to put our answer as 29.45 degrees. We're going to start by just drawing the line y equals minus 2. So the line y equals minus 2 will be a horizontal line at minus 2, which will be down here. Next, we're going to do the line x equals minus 1, and that will be a vertical line at minus 1. Now, here's a bit of a problem. We've got no equal to underneath it, and whenever we don't have an equal to, we do a dash line. So we're going to do a dash line here. Okay, the last graph is a little bit harder. We've got y is, or I'm going to do y equals x minus 3, and it's going to be a perfectly diagonal line, but down to minus 3. So it's going to be this line here, about there, but it's going to be dashed because we don't have an equal to. So it's going to be a dashed line like that. So if they have an equal to underneath, then it will be a solid line. If they don't have an equal to underneath, it will be a dashed line. Okay, now we've got to work out where the region is. So we've drawn the lines, and the lines are either dashed or solid, and so they're perfect, but we've got to work out where the region is. So we can see on the first one that y is greater than or equal to minus 2. So it's going to be above this line. Okay. You can see on the next one that x is greater than minus 1, so it's going to be this side. So we've already narrowed it down to somewhere in this region here. And here we're given that y is greater than x minus 3. So what we do here is we pick a point. So I'm going to pick a coordinate, and I'm going to pick 0, 0. 0, 0 is always my go-to one. Write out the equation, and I'm just going to put a box here. So x minus 3, and fill in the coordinates for 0, 0. So 0, blank, 0 minus 3, 0, blank, 0 take away 3 is minus 3. So what is 0 compared to minus 3? Well, 0 is greater than minus 3. And therefore, this coordinate is on the correct side, because if we look, we've got y is greater than x minus 3 is our region that we're looking for. So we're looking for that, that's good. And so our region will be anywhere in this bit here. Anywhere at all. And you're asked normally to mark it with an R. I'm kind of colouring it in just because your R can be anywhere within this region. It can actually be at 0, 0. Anywhere within the yellow region would give you the mark. So we're told that y is proportional to x squared. And the first thing I'm going to do is replace that proportionality sign with an equals. And to do that, I've got to times the right hand side by k. So we get y equals kx squared. Then I'm going to replace the x and the y for the values given to find out what k is. So y is 75 when x is 5. So we know that 5 squared is 25. And then just quickly solve this. So I'm going to divide both sides by 25, and as you can quickly see, should be 25. As you can quickly see, k is going to equal 3. Rewrite the equation. So I'm just going to rewrite this, but with k as 3. K is a constant, so we know that that will be correct for all values of y and x. Then it says find the value of x when y is 12. So I'm going to replace the y for 12 and then just simply solve. So I'm going to start by dividing both sides by 3. Then I'm going to square root both sides. So we've got the value of x equals 2. Okay, so first thing I'm going to do is just a quick sketch of this diagram. And so we're told the lengths are 8 and 6, and the angle between the lengths is 64 degrees. And we've kind of got a missing length down here which we need to find. So we need to find that one. Okay, so let's label them. Now we're going to be using the cosine formula. So cosine formula involves angle A. So we're going to label the angle A. And the one opposite, the one we label as A, is going to be little a. And then little b and little c, it doesn't matter. Right? It doesn't matter which way around you do them. So we're going to write down the cosine formula. So it's a squared equals b squared plus c squared minus 2bc cos a. And so that would be x squared equals, and that will be 8 squared plus 6 squared minus 2 times 8 times 6 times cos 64. And that will be x squared equals 57.916 blah blah blah. And we just need to solve this, and we can solve it by just square rooting both sides. So it would be x equals 7.61000 blah blah blah. Okay, we're asked for the perimeter, and so we need to do 8 plus 6 plus that 7.610 blah blah blah. I've still got on my calculator, and that equals 21.610 blah blah blah. It says it wants its 2 decimal places, so it will be 21.61. So we're given the equation of the line, which is y equals ka to the power of x, and we're given two coordinates. So we're looking at this first coordinate and put that into the equation. So y is 10 equals ka to the power of x, which is 1. And we're going to do the same with the other coordinate. So we've got 40 equals ka to the power of x, which is 3. Now look at what's happening to both sides. Here we're multiplying by a squared. So a to the power of 1 times a squared is a to the power of 3. And on this side we're multiplying by 4. So we have to be able to conclude that a squared equals 4. And if we square root both sides there, a must equal 2. So if a equals 2, we can just put that into the first equation here. So we've got 10 equals k times 2. And divide both sides by 2, and we get 5 equals k, or k equals 5. So our answers will be k equals 5 and a equals 2. Now check that works. So let's have a look at this second coordinate, and we're going to do y equals, and we're going to do 5 times 2 to the power of 3. 2 to the power of 3 is 8. 5 times 8 is 40. So we know that our equation works. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x. So half of the 10 would be 5. Close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, well, across here, I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here, it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. I'm going to leave the 3 on the outside of the x. In fact, let's keep the colour scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. A normal sine wave starts at 0, goes up to 1 at 90, down to 0 at 180, down to minus 1 at 270, and then back up to 0 at 360. But here we're given a plus 45 inside the function. Now, a plus 45 actually does the opposite of what you think. You would think that it would move it right 45, but it doesn't. It moves it left 45. So each of these points we're going to move to the left by 45 degrees. So instead of at 91, this is now going to be at 45, 1. And each of these are just going to move left 45 degrees. Now 45 degrees is 2 squares. So it's just 2 squares worth of moving left. And so we get a really horrible start to this because we don't really know where it's going to start. It's going to start somewhere there. And then we've got a nice U shape and then down to here. These types of graph are not the easiest to do because they're stretched out, but make sure you have a U shape at the bottom there. And then we kind of guess here that it's going to go somewhere there. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.